Hello student, welcome back. We are going to start today's session. It is Lecture 1, Module 2, Microcontroller and Embedded System. Shongita Roy, Assistant Professor, Electronics and Communication Engineering Department, Narula Institute of Technology. Today's content is 8051 Addressing Modes and Instruction Set. And under this topic, we will discuss different modes of 8051. So this is the pin diagram and block diagram inside of PEEK microcontroller. In 8051, there are 1 byte, 2 byte instructions and very few 3 byte instructions are present. The opcode are 8-bit long. As the opcodes are 8-bit data, there are 256 possibilities. Among 256, 255 opcode are implemented. The clock frequency is 12 MHz, so 64 instruction types are executed in just 1 microsecond, and rest are just 2 microseconds. The multiplication and division operation take 4 microseconds to execute. 8051, there are 6 types of addressing modes: immediate addressing mode, register addressing mode, direct addressing mode, register indirect addressing mode, index addressing mode, and implied addressing modes. Immediate addressing mode. In this immediate addressing mode, the data is provided in the instruction itself. The data is provided immediately after the opcode. There are some examples of immediate addressing mode. Move A, hash 0AFH. Move R3, hash 45H. Move DPTR hash FE00H. Now, immediate addressing mode, one example is move A, hash 6AH. In general, we can write move A, hash data. This addressing mode is named as immediate because it transfers a 8-bit data immediately to the accumulator, destination operand. So, instruction is move A, hash 6AH. Its opcode is 74H, byte is 2 bytes. Cycle means time requiring 1 clock cycle. So there is program memory. It is in the address 0203, it is 6A, and address 0202, it is 74. So in 0202, it is opcode and data is in 0203. So if program counter is equal to PC, then PC plus 2 because it requires 2 addresses. So the program counter next address will be 0204. Initial address is 0202, then it is incremented by 2. So the after execution it will take the program counter to 0202. The picture above describes the above instruction and its execution. The opcode for move A, hash data is 74H. The opcode is saved in program memory at 0202 address. The data 66AH is saved in program memory 0203. So see the earlier one. The data is 0203 and the opcode is 0202. When the opcode 74H is read, the next step taken would be to transfer whatever data at the next program memory. Here at 0203 to accumulator A, E0H is the address of accumulator. This instruction is of 2 bytes and is executed in 1 cycle. So after the execution of this instruction, Program counter will add 2 and move to the program counter 0204 of program memory. In this instruction, the hash symbol is used for immediate data. In the last instruction, there is DPTR. The DPTR stands for data pointer. Using this, it points the external data memory location. In the first instruction, the immediate data is AFH, but 10 is added at the beginning. So when the data is starting with A to F, the data would be preceded by a 0. Register addressing mode. In the register addressing mode, the source or destination data would be present in the register R0 to R7. These are some examples of register addressing mode. Move, move A, R5, move R2, hash 45H, move R0, A. In 8051, there is no instruction like move R5, R7, but we can get the same result by using this instruction move R5, 07H or by using move 05H, R7. But these two instructions will work when the selected register bank is RB0. Use another register bank, and to get the same effect, we have to add the starting address of that register bank with the register number. For an example, if the RB2 is selected and we want to access R5, then the address will be 10H plus 05H is equal to 15H. So the instruction will look like this: move 15H R7. Here is 10H is the starting address of register bank 2. Direct addressing mode. In direct addressing mode, the source or destination address is specified by using 8-bit data in the instruction. Only the internal data memory can be used in this mode. Here are some of the examples of direct addressing mode. Move 80H, R6, move R2, 45H, move R0, 05H. The first instruction will send the content of the register R6 to port 0 of address 80H. Therefore, 80H indicates the address of port 0. The second one is forgetting content from 45H to register 2. See again. So 45H, this content will be transferred to register 2. The third one is used to get data from register R5 to register RB when the register bank RB0 is selected to register R5. Move A, 04H. Here 04H is the address of register 4 of register bank 0. When this instruction is executed, whatever data is stored in the register 04H is moved to the accumulator. In the picture below, we can see the register 04H holds the data 1FH. So the data 1FH is moved to the accumulator. So the program memory contains the address 04 and corresponding 04 has a value, whatever with the value of 04, say here it is showing 1F, that this value will be transferred to the accumulator. Similarly here, the after execution program counter address will be when it was initiated plus 2. Therefore, in the starting it was 0202, after execution it will be 0204. As shown in the picture above, this is a 2-byte instruction which requires one cycle to complete. Program counter will increment by 2 and stand in 0204. The opcode for instruction move A address is E5H. When the instruction is at 0202 is executed, E5H accumulator is made active and ready to receive data. Then the program control goes to the next address 0203 and look up the address of the location of the 04H where the source data to be transferred to the accumulator, and in the corresponding location the data is stored and the data is 1F and that is transferred to the accumulator and the execution is completed. Register direct addressing mode. In this addressing mode we use the register name directly as source operand. An example is shown below. Move A R4 at a time register can take value from R0, R1 up to R7. You may already know there are 32 such registers. So how you can access 32 register with just 8 variables to address register. Here comes the use of register bank. There are 4 register banks, namely 0, 1, 2 and 3. Each bank has 8 registers named from R0 to R7. At a time only one register bank can be selected. Selection of register bank is made possible through a special function register named processor status word PSW. PSW is an 8-bit SFR where each bit can be programmed. Bits are designed from PSW 0 to PSW 7. Register banks are selected using PS3 and PS4. These two bits are known as register bank select bit as they are used to select register banks. A picture below shows the PSW register and register bank select bit with status. So there are 4 register bank 0, 1, 2, 3. So RS1, RS0, these are the combination with register bank. When it is 00, register bank 0 is selected. When it is 01, register bank 1 selected, 102 selected and 113 is selected. Register bank status. Register bank 0 is selected, register bank 1 is selected and so on. So PSW what status? The 7th bit is carry status, 6th bit is accumulator, 5th bit is F0, 4th bit is RS1, 3rd bit is RS0, 2nd bit is for 0 volt and 1 is not used and PS0 is for parity. So in register direct addressing mode, data is transferred to accumulator from the register bank, that is based on which register bank is selected. From this selection the bank register is selected. So it is shown over there. Register direct addressing mode instruction move A, R4. Opcode is ECH, byte is 1, cycle is 1. So ECH is stored in the address 0202 and it is EC and corresponding the value stored is 0C it is 24 and 04 it is 24. Finally it will from the RB0 it will transfer to RB1. So initially it was in RB0 program counter, it was earlier. After this operation it is 1 as it is 1 byte. So after this execution program counter address will be 0203. So after execution it will go to the accumulator. After this accumulator it will transfer to the register R4 to accumulator and it will go to the register 1. So we see that opcode for move A, R4 is executed. The opcode is stored in program memory address 0202. When it is executed, the control goes directly from R4 of the respected register bank that is selected PSW. If register bank 0 is selected, then the data from R4 of the register bank 0 will be moved to the accumulator. Here it is 2F stored in 04H. So 04 is the address of R4 of the register bank 0. Movement of data 2F in this case is shown as bold line. Now take a look at the dotted line. Here 2F is getting transferred to the accumulator from the data memory location 02H. Again show the previous one. It will be clear. So it is transferring from RB0 to RB1 from register 4 to the accumulator. Now understand that 0 to H is the address location of register 4, R4 of register bank 1. Programmers usually get confused with the register bank selection. Also keep in mind that data at R4 of the register bank 0 and register bank 1 or even other bank will not be same. So wrong selection of register bank will result in undesired output. Also note that the instruction above is 1 byte and requires 1 cycle for completion. This means register direct addressing mode can save program memory. Register indirect addressing mode. In this mode, the source or destination address is given in the register by using indirect addressing mode. The internal or external address can be accessed. The R0 and R1 are used for 8-bit address and DPTR is used for 16-bit addresses. No other register can be used for addressing purposes. Let us sum up the examples shown below. Move 0E5H, @R0, move @R1, 80H. These are the some examples. In the instruction, the @ symbol is used to register indirect addressing. In the first instruction, it is showing that the register R0 is used. If the content of R0 is 40H, then the instruction will take the data which is located at location 40H of the internal RAM. In the second one, if the content of R1 is 30H, then it indicates that the content of port 0 will be stored at location 30H in the internal RAM. 80H of R1, it indicates a port. Move XA, @R1, move @DPTR, A. In these two instructions, the move X indicates the external data memory. The external data memory can only be accessed in register indirect mode. In the first instruction, if the R0 is holding 40H, then A will get the content of the RAM location 40H. And in the second one, the content of A is overwritten in the location pointed by DPTR. It is a pointer. Move A, R4. At a time, register can take value from R0, R1 to R7. You may already know there are 32 such registers. So how you can access 32 registers with just 8-bit variables to address registers? Here comes the use of register banks. There are 4 register banks, 0, 1, 2 and 3. Each register has 8 registers named R0 to R7. At a time, only one register bank can be selected. Selection of register bank is made possible through a special function register SFR named processor status word PSW. PSW is an 8-bit SFR where each bit can be programmed. Bits are designated from PS0 to PS7. Register banks are selected using PS3, PS4. These two bits are known as register bank select bits as they are used to select register banks. So in the addressing mode, address and data is given in the register operand. Move A, comma, @R0. Here the value inside R0 is considered as an address which holds the data to be transferred to the accumulator. Example, if R0 holds 20H and we have a data of 2FH stored in the address 20H, then the value of 2FH will get transferred to the accumulator after this execution. So it is showing here how it is operated. It is a 1 byte instruction, it takes 1 cycle. So after execution, PC is equal to PC plus 1. So initial register program memory is 0202. Then after execution, the next location will be 0203. And here is the operand is E6H, and 0202 it contains EC. So after after operation, the value from the location 20 to from 20, it is stored the value 2F. It will be transferred to the accumulator because R0 contains the address and that address contained the data 2F, and after execution this data will be transferred to the accumulator. So the opcode for move A, comma, @R0 is E6H. Assuming that register bank 0 is selected, so the R0 of the register bank 0 holds the data 20H. Program counter moves to 20H where it locates the data 2FH and it transfers 2FH to accumulator. Indexed addressing mode. In the indexed addressing mode, the source memory can only be accessed from program memory only. The destination operand always a register A. These are some example indexed addressing modes. Move CA, comma, @A plus PC. Move CA, comma, @A plus DPTR. Where C is move C instruction referred to code byte. For the first instruction, let us consider A holds 30H and the PC value is 1125H. The content of the program memory location is 1125H is 30H plus 1125H are moved to the register A. Implied addressing modes. In the implied addressing mode, there will be a single operand. These types of instruction can work on specific register only. These types of instruction are also known register specific instruction. Here are some examples: RLA, SWAPA. These are 1 byte instruction. The first one is for rotate the register A content to left. The second one is used to swap the nibbles in A. Move C A @DPTR, A plus DPTR. Move CA @A plus PC, where DPTR is data pointer, PC is program counter. Move CA @A plus DPTR. The source operand is @A plus DPTR, and we know we will get the source data to transfer from this location. It is nothing but addressing contents of the DPTR with present content of the accumulator. This addition will result a new data which is taken as the address of the source data. The data at this address is then transferred to the accumulator. So this is the concept how it is occurring. So total DPTR is equal to 0 1 that is to 8 bit, then FE that is to another 8 bit, upper 8 bit, lower 8 bit. So total is 16 bit. This is added with the content of the accumulator. So after this addition, the content is stored as data in the program memory. And the opcode is 93H. The opcode for the instruction is 93H. DPTR holds the value of 01 FE, where 01 is located in DP higher value, higher 8 bit. FE is located in the lower 8 bit. Accumulator now has the value of 02H. 16 bit addition performed, so 01 FE H plus 02. So the result is 0200H. Whatever data is in 0200H will get transferred to the accumulator. The previous value inside the accumulator was 02H will get replaced with a new value. This is a 1 byte instruction with 2 cycles needed for execution. The execution time required for this instruction is high compared to the previous instruction. The other example, move C A at a rate A plus PC, works the same as that of this one. So these are the references. Thank you. We are ending the session.